Hey, hello, this is Mrs. Lim, and this is the video about radioactivity, okay, or radiations. I'm going to skip the front part about the composition of an atom because you have learned majority of it in chemistry. So we'll just zoom directly into the radioactive part of radioactive nuclide. Okay, so in this first section, okay, we are going to move okay, to cover about what is radioactivity exactly. Okay, and in this section, we will be covering the following learning outcomes. Firstly, you need to understand that nuclear decay is a random and spontaneous process. So I'll go about explaining what does it means by random and what does it means by spontaneous process. And in the process of radioactive decay is when an unstable nucleus loses energy by emitting radiations. And then there are three types of ionizing radiations that comes out from an unstable nucleus. They are alpha, beta, gamma. You need to know about the nature of them, their characteristics and their properties. And then also in this video, we will use equations involving nuclide notations to represent changes in the composition of the nucleus. So in general, it's about writing equations to represent nuclear decay. Okay, for the last two bullet points, we will move on to the second part of the video, which will not be shared in this video. Okay, so the first part, okay, whenever we say that a radioactive nucleus is undergoing decay, the decay is a random process, okay, and a spontaneous process. So the entire definition of what is nuclear decay or radioactivity, these three terms have the same meaning. It's just, it means that it's the random process in which an unstable nucleus loses its energy through emissions of electromagnetic radiations or particles. Okay, and why is it that certain nucleus is unstable? Certain nucleus emits uh, all these radiations or particles is because there is a imbalance of nuclear forces within the nucleus, okay, to bind the nucleons together. Okay, you should have learned in chemistry that in the nucleus of an atom, it consists of protons and neutrons, okay? And usually if the nucleus is so what we call stable, okay, the number of protons and neutrons will be such that there will be a force of attraction holding the protons and neutrons close together in the nucleus. Okay, and this force of attraction is called the nuclear forces. And usually, for a stable atom, the nuclear forces is sufficient to hold all the neutrons and protons together. Nothing is going to happen. Then it's called a stable nucleus. But in certain cases, some of the atoms have a slight change in its properties or whatever that causes the proton number and the neutrons number to vary. Usually they are isotopes. You know, isotopes are atoms with the same number of protons but different number of neutrons. So like carbon, you know, carbon, the standard carbon is carbon 6 carbon 6 protons, 12 for protons and neutrons, the mass number. But then there's also isotopes, there's carbon 14. Okay, so with different isotopes, sometimes the protons and neutrons number changes, and then this causes the nuclear force to be uh, imbalance, and with the imbalance of nuclear force, then we say that the nucleus becomes unstable. And when the nucleus becomes unstable, it will always try to become stable itself. So it tries to become stable by emitting this electromagnetic radiation, which is your gamma rays, or emitting particles, which is your alpha or beta particles. Okay, so certain terms to take note of for a start is the nucleus or the nuclei that is unstable and is going to emit radiation to make itself stable is called radioactive isotopes, or we just call it a radioactive nucleus. And then the things that comes out, okay, the electromagnetic radiation or the particles that comes out, your alpha, beta, gamma particles that's going to come out, okay, they are called ionizing radiation or because they comes out because of a nuclear reaction, we call them a nuclear radiation. Okay, but we say that the atom itself is radioactive, but the alpha beta particles that comes out, they are ionizing. They are not radioactive. They are just ionizing. Okay, what does ionizing means? Means that it is able to ionize other things, means it's able to knock out electrons from other atoms so that other atoms becomes ions. And when other atoms change from atoms to ions, there's a change in property of that material, and that's why it's dangerous. You change the nature of the substance by knocking out electrons. Okay, so we say that it has the ability to knock out electrons. It's not radioactive, but it has the ability to knock out electrons. So we say that it's ionizing. Okay, but they are not radioactive. The part that is radioactive is the nucleus. The unstable nucleus itself is radioactive. Okay, so a pictorial diagram looks like this. So you have the nucleus of an atom. So the nucleus have protons and neutrons together. Okay. So if normal case is stable, means the forces, the nuclear forces holding the blue and the red balls are very strong. Okay, no protons and neutrons will come out of it. It's called a stable one. But sometimes because of the different number of protons and neutrons, it becomes unstable. So once it becomes unstable, it tries to become stable by emitting particles. Okay, you can see this green ball particles, alpha or beta particles, or it can emit radiations, ionizing radiations, like your gamma rays, which is part of your EM spectrum. That's why it's called electromagnetic radiations as well. Okay, so it emits this already, then after emitting this, then it becomes a stable one. So we call this one that is emitting the alpha, beta, gamma, we call it a radioactive nucleus. It is radioactive. Okay, and then all these are called the ionizing radiation or particles. Okay, and then it is a spontaneous and random, okay, process. Spontaneous means it will just happen naturally. Nothing can stop it. Nothing can affect it. Once the nucleus is unstable, it will definitely emit alpha, beta, or gamma in order to become stable. It is not being controlled by temperature, pressure, or any other external factors. Not say, oh, I heat it. If I hit something, I hit an atom, it will emit out alpha, beta, gamma. No, it is not like, oh, I apply high pressure, then it will stop emitting. No. Okay, it's spontaneous means it will definitely happen, cannot be controlled by any factors. Okay, random can be random in time and direction. Okay, what do I mean by random in time? It means that you cannot predict when is an alpha particle or when is a gamma ray going to come out of the nucleus. It can come out this second, or it can come out 3 seconds later or 10 seconds later. You cannot tell. Okay, it will be constantly coming out, but you cannot tell exactly when or which atom or which proton or which neutron is the one that is giving out the radiation at any point of time. It's random in time. It's also random in directions. Random in direction in terms of the alpha particles, beta particles, or the gamma rays that comes out. You cannot determine which direction will it come out. Some will come out from the left, some will come out from the top, some will come out from the right or bottom. You cannot predict which direction is the particles going to be emitted out. So it's called a random process. Cannot determine the time and cannot determine the direction that's going to come out. But it's spontaneous means it will definitely happen, cannot stop. Okay. Okay, so that's what it means by nuclear decay is a random and spontaneous process. It will definitely happen. You cannot predict the time and the direction. Okay, and it decays because the nucleus is unstable. Okay, so this is what I just mentioned. Okay, you can read through yourself. Okay, then we zoom into uh, the particles or electromagnetic radiation that comes out from a radioactive nucleus. Okay, there are three different types, which you must know as the key part of this chapter. Okay, together with half-life, which is in the next video. Okay, so the three types of ionizing radiation or nuclear radiation that comes out from a radioactive nucleus are alpha particles, beta particles, and gamma rays. Okay, three types. Okay, so they have slightly different properties because they are slightly different. Okay, and then it is okay. So we will zoom into what are the nature of alpha, beta, and gamma radiations, and then also how is their penetrating power, how is their ionizing effect, and then whether it's being affected by an electric field or a magnetic field. Okay, so these are the few things that we are covering. So you can see from this diagram, okay, we have a alpha particle. Alpha particle looks like this red one. Okay, so the symbol is like this. Okay, a little bit like A, but it's not A. Okay, then you have beta particles, the blue particles, the symbol is like this. And then you have a gamma ray, the symbol is like this. Okay, so you can see that over here, these three particles are having a race, and then there's some obstacles. Okay, the obstacles is ability to test the penetrating power of each particles. And you can see that this one very brave. I will win because I can pass through obstacles very easily. Means I can pass through many things. I'm very highly penetrative. This one I can only pass through one, and then the alpha is I don't think I can pass through any. Okay, so we zoom into it. Okay, so this is the part that I talk about. They are all called ionizing radiation, okay, because they all have the ability to knock out electrons from atoms to form ions. So when I have all these alpha, beta, gamma passing through the air, they can actually knock out uh, electrons from the air particles. So the air particles becomes charged, positive charge and negative charge. Okay, so just take note that ionizing radiation is not only confined to alpha, beta, gamma. You have learned previously in your EM waves, okay, your gamma rays, X-rays, ultraviolets are all ionizing radiation. But gamma rays, because gamma rays comes out from nuclear decay, so we say that it's a radioactive radiation or yeah, radioactive radiation. But then for ultraviolet and X-ray, although they are ionizing radiations, but they don't come out from nuclear processes. So we just call them ionizing radiation in short. Okay, so let's zoom in. Okay, so there are three types. Okay, you can see the symbol over here. So alpha particles, beta particles, gamma rays. So these are the symbols. Okay, the symbols are being recognized. So you can just use the symbols when writing the formula equations. Okay, but in terms of writing long structured questions, it's preferred that you spell out alpha, beta, and gamma. Okay, so alpha particles, let's talk about the nature first, okay? Alpha particles is actually two protons and two neutrons. Two protons, two neutrons. There is no electrons. Okay, so just two protons and two neutrons together. So it looks like that, two protons, the two red one, plus, and two neutrons, the black one. Okay, so this entire thing, okay, is called an alpha particle. Okay, it's very similar to a helium nucleus because you know that your helium is also 4-2. Okay, the nuclide notation, two protons and four protons plus neutrons. Okay, just take note that it's a helium nucleus. It's not a helium atom because a helium atom consists of two electrons surrounding it. Okay, there is like this, the nucleus, plus 2 electrons. That the whole thing is called a helium atom. But this one don't have the 2 electrons surrounding it. It's just the nucleus part. So we just say that it's a helium nucleus. Okay, so the symbol you can either write alpha 42, or you can also write, or you can also write like this, helium 42. Okay, it's also recognized as alpha particles. Okay, next one, let's talk about beta. Beta particles is just electrons. Electrons. Okay, so electrons have a charge of -1, no neutrons. It's just an electrons. Okay, you can write as this beta symbol, or you can write as this. Oops. Okay, or you can write as this. Okay, you must be able to write the nuclide notation. Okay, because it's important in generating the formula later on. Nuclide equations. Okay, so beta one is just electrons, and gamma rays are just electromagnetic waves. They have no charge, okay, and they are just electromagnetic waves. Okay, so these two alpha and beta are particles, and gamma rays are not particles, they are radiation. Okay, so they have a charge. Okay, I'm just going to add on over here. Okay, so because alpha particles have no electrons, but it has protons, so it has a charge of +2. Okay, and then for beta particles, it has a charge of -1 because it's an electron. Okay, and for your gamma rays, okay, because it's not uh any protons or electrons, it's just a radiation, it has no charge. It has no charge. Okay, so you might want to add on this in your textbook. Okay, then next we go into its ionizing effect as well as its penetrating ability. Okay, its ionizing effect means its ability to knock out electrons as it passes through a material. Knock out electrons from the atoms as it passes through the material. Okay, so alpha particles has the highest ionizing effect. That means it's very powerful in ionizing, which also means that it is the most dangerous radiation, because when it passes through anything, it's able to knock out electrons very easily. And when it knocks out electrons from something else, it changes the property of the material, which is why it's dangerous. When it passes through your body cells, it knocks out electrons from your body cells, and then it alters the behavior of your body cells. Your body cells cannot function properly. You get mutation, you get cancer, and etc. Okay, so alpha particles has the highest ionizing radiation. How do you know alpha particles has the highest ionizing rate effect? Okay, firstly, you need to know that out of these three, the particles are heavy. Okay, it has a mass of 4, relative mass of 4 compared to an electrons. Is the biggest particle. A helium nucleus is definitely bigger than an electron, and electron is super small. Okay, so this one is the biggest. Okay, it's the biggest particle and it's the heaviest particle. It has a relative mass of 4. So I'm going to jot down here. You may also want to jot down. Okay, it's the biggest and heaviest out of all. Okay, so what does it mean by bigger and heavier means? It means that it moves very slow. And when it moves very slow, it's able to interact with the materials around it more. Okay, and because it is bigger, heavier, it has more protons, more neutrons, it is able to knock out other electrons easier because it's massive, easy to knock out other atoms. Okay, easy to knock against other atoms. Okay, it travels very slow, very easy to knock out. Okay, because it interacts a lot with the materials around it. Okay, beta particles, on the other hand, have medium because I am smaller, much smaller than helium, and I move much faster because I'm lighter. I'm only electron. You know, the mass of an electron is almost negligible, 1/1840, almost negligible, very small mass. So I move quite fast. So I don't stay at one spot and interact with the materials around me very much. And because I'm much smaller, I don't really have much energy to knock out electrons from others. I have energy, but I don't have as much as alpha particles. And for your gamma rays, super fast because their radiation, they travel at the speed of light 3 times 10 to the power 8 meters per second. They travel super fast. Okay, so they are very fast. So they don't stay and interact with the material much. So they have the least ionizing effect. Okay, uh they do knock out, but it's not as much as alpha particles. So it has the lowest ionizing effect. So I would say that if you are exposed to all three, which one is the most dangerous? Your alpha particles. Which one is the safest? Gamma. Although gamma is not safe, also it's able to still ionize things, so it's not safe, but it's the least ionizing. Okay, then we talk about the penetrating ability. Penetrating ability is its ability to pass through materials. Alpha particles have very strong ionizing effect, but one thing good is because it travels so slowly, it spends a lot of time interacting with the materials around it. It can only travel a very short distance and then it will be gone. It will lose all its energy trying to knock out electrons from other materials. So it loses its energy very fast, then not enough energy, cannot move on anymore, cannot pass through any more materials. So the penetrating ability is the least. Okay, they can be absorbed by a few cm of air. It doesn't travel very far. As by a piece of paper or just the human skin. It cannot even enter your body unless you ingest it, you eat it, or you breathe it. Okay, otherwise it will be stopped by your skin. It cannot even pass through your skin. Okay, because it's moving too slow. It's too big, move very slow, spending too much time interacting with the air and the surrounding. Okay, so it's stopped by paper, human skin, or a few cm of air. Okay, on the other hand, beta, uh, medium penetrating power. Okay, because travel quite fast already. Okay, they are not absorbed by paper. They can easily pass through paper, can pass through the skin of the human beings, but they are absorbed by a few thick of aluminum foil. Okay, aluminum foil. Okay, aluminum or any aluminum, any metal, a few thick of aluminum, which is very thin. Okay, a thin sheet of aluminum will block the beta particles. But for gamma rays, they travel so fast, 3 times 10 to the power 8 meters per second. They don't really spend a lot of time interacting with the materials that they are having, that they are in contact with. They just spend a lot of energy keep moving. So they have the highest penetrating ability. They can pass through paper, can pass through aluminum foil, but they can be stopped by lead, okay, a few cm thick of lead or very, very thick concrete. Okay, so usually we want to prevent radioactive materials from leaking out in a nuclear power plant. We usually we usually place the radioactive substance in a cylinder that's made of a few cm thick of lead. Okay, so that everything cannot pass through the lead, everything will not leak out of the lead container. Okay, because yeah, the highest one is gamma rays. Okay. Okay, next one. So this is a summary of what happens. Alpha particles, which is helium nucleus, stopped by paper, cannot pass through paper. Beta particles move a bit faster, doesn't interact so much, doesn't ionize the material so much, but it can pass through paper and stop by a few thick of aluminum. And gamma rays, very little ionizing effect, okay, because it doesn't stay long in one place. It just goes straight very fast, 3 times 10 to the power 8. It just pass through paper, pass through uh, aluminum foil, and is stopped by a few cm thick of lead. Okay, so this one must memorize. Okay, next. Okay, so this is a picture of, okay, I will not play the video. Okay, so I will not play the video. I'll just let you see this. You can watch the video yourself. So what happens here is, you can see a human being exposed to alpha, beta, gamma. Alpha, very ionizing, okay, very harmful to the human body, but luckily stopped by the skin. Beta particles can pass through the skin, okay, medium ionizing effect, but usually it doesn't isn't very bad because it is being stopped by your muscles, your fat tissues, and all the other tissues. Okay, and then your gamma is the one that is used in radiotherapy to kill cancer cells. We use gamma rays instead of alpha and beta because gamma rays are highly penetrative and the ionizing effect is the least. We don't want it to immediately kill all the cells. Then your healthy cells will die first. Okay, because it passed through, then it will kill your skin cells, your muscle cells, your whatever fat tissue cells, everything also kill. Okay, so we don't want it to kill so much cells, but we want it to be able to penetrate to reach the different organs or to reach the different parts of the body. So gamma rays can pass through everything, but it has the least ionizing effect. Okay. Okay, then next one, a little bit additional. This is not in your textbook, but is frequently asked in a few questions. So I'm going to include it in the PowerPoint slides. So we also need to look at how alpha, beta, and gamma particles are reacting in a electric field or a magnetic field. Okay, that will depend on whether they are charged or uncharged. So in an electric field, okay, in an electric field, alpha, beta, okay, alpha and beta are charged. Alpha is positively charged, beta particles are negatively charged, and gamma rays are uncharged. And because they are charged, they will be deflected, okay, in electric field and magnetic field. So I show you a picture. So you can see that beta particles are negative, -1. Alpha particles are +2. So the positive one will bend towards the negative plate in an electric field, and the beta particles will bend towards the positive plate. Gamma will not be bent. And similarly for magnetic field, this one you need to use your Fleming's left-hand rule. I'll not go in depth. You can see yourself. This is the movement of a positive charge. Okay, that means the direction of current. And this is the movement of direction of electron. So the current will be backwards instead of forwards. You will see that the beta electrons is lighter, so electrons will bend more. Alpha will bend very little because alpha is very heavy, so it doesn't bend that much. Okay? Okay. Okay, next then we move on into writing equations to represent radioactive decay. So during radioactive decay, we have just covered before there is 3 types of emissions, alpha particles, beta particles, or gamma radiations. So we usually write what we call a nuclide equations using nuclide notations to represent the changes in the composition of the nucleus to show what has happened to the nucleus during radioactive decay. So for example, over here, radium is a chemical substance, okay, and then it is an unstable nucleus, okay. So the unstable, the radioactive nucleus or the radioactive isotopes is radium with a proton number of 88 and a mass number or nucleon number of 226. So this is the nuclide notation for radium. Okay, because it is unstable, it tries to be stable by emitting an alpha particles. And after emitting an alpha particles, it has changed its properties because the proton number is no longer the same. You should have learned in chemistry that proton number determines the identity of a substance. So because the proton number change, it becomes a new substance. The new substance is radon. Radium becomes radon, Rn. Okay, so how do I balance it? Okay, it's just like chemistry. You need to make sure that the proton number and the neutron number, nucleon number stays the same on both sides of the equation. Then the arrow means, I mean, the reaction is going forward lah, from radium to radon. Okay, so radon Rn. Okay, I do not know what is my number over here, but I know I emits an alpha particle, and the alpha particle is a helium nucleus. So I can use helium 24, or I can use the alpha symbol 24. It's fine. Okay, so since this side I have two already, so in order to make 88, this side will be 86 for the proton number of radons, and the nucleon number, this side already 4, so I just need 222 because 222 plus 4 will give me 226. Okay, so you can see that the nucleon number and the atomic number balance on both sides of the equation. Okay, that's for emissions of alpha particles. Next, we move on. Oops. Please. Next, we move on to beta decay, or the release of a beta particles. Beta particles are electrons. You can do this E minus 1 and 0, or the beta symbol minus 1 and 0 is fine. So you have carbon 14 emits an beta particles and it decays to nitrogen. So your carbon 14 will be like this, 6 and 14. After decay, okay, I will have beta particles that comes out, minus 1 and 0. And because I have this minus 1, this side must be 1 more. So it's 7, because 7 minus 1 will give me 6. And then the nucleon number doesn't change because it's 0 over here. So nucleon number stays the same. So it becomes a nitrogen atom. Okay. And then next, okay, gamma radiation. Gamma radiation, you know that gamma radiation doesn't have any protons, doesn't have any neutrons. It's a radiation, it's not a particle. Okay, so just take note that when nuclei decay, it doesn't only undergo alpha or beta decay. Sometimes it undergoes alpha and beta. Sometimes it undergoes alpha, beta, and gamma radiation. Okay, it can be multiples. Okay, different types of radiations. Particles or radiation that comes out. Okay, so example, uranium emits an alpha particles and then becomes chromium, and two gamma rays of different energies are also emitted at the same time. So uranium come out alpha, come out gamma. So uranium is 92 and 238. Okay, it becomes thorium. Okay, it emits an alpha particle. So I have a helium nucleus here, 24, and gamma ray, okay, 00. Okay, it's not really necessary to write this 00. You can just write 2 gamma, it's fine. But if you want to write the 00, it's not wrong as well. Okay, so I already have 2 here. I want to make 92, so my thorium will be just 90. And then over here, I already have 4, so I only need 234 to balance up to 238. Okay, can? Okay, so basically that's it.